Good morning. I am Leon Buerta from All About Drones. We are doing a short little video to show you how data would be utilized that comes from our drone surveys of bridges or any other type structures or areas. Here in the background, I've got a PDF drawing. This is typical output of a drone survey of a bridge. On the left-hand side there, that's the site plan. This is a plan view of the bridge deck, an elevation, maybe some close-up details of the abutments and alignment, which was quickly done for this survey. One would not normally have output like this for a model, but if it is requested, then we can produce drawings from models. But we normally anticipate that the client would do their own drawings if it's necessary, or just make use of the models themselves. So how was this achieved? A survey was done in the field, 223 photographs that was flown, and from that a dense point cloud is generated. You can see there's no real detail underneath the bridge because this is only a top-down survey. And this then is taken to other programs where everything that's vertical is stripped off, and the lowest points between grass is found, and you write out a grillage of points which are then ground-only surface points, which is taken into Civil 3D, where a digital terrain model is produced, and contours are then taken from that. And this is what you have here. I'm opening Civil 3D. Here we have the contours that was generated in Civil 3D. And the drone survey orthophoto is placed in the backdrop, and that is what is typically then what you see on the drawings. We normally make the photogrammetry image, or orthophoto, or orthomosaic as it's also called. We fade it out a little bit so that the drawn entities can be better seen, things like dimensions and text and so on. Okay, so the next step then was to actually produce to fly and model the bridge. Same side elevations also captured, and the photographs that is from the underside, that we actually capture by physically walking with the drone, setting it on a time interval of maybe 2 seconds and tilting the camera upwards, and then capturing images from the side to try and model the sides and portions of the soffit of the bridge. Okay, this then is written out in a 3D model file, and we help our clients by installing a free software model viewer that accompanies this data. So I've just loaded the 3D viewer. I'm starting by opening Add Layer, and there's the TLS file for the model. It's quite large, it's 2.5 gigabytes, and very, very smooth. Look how rapidly it loaded, and what's happening in the background, it's adding detail. So as you zoom in, more and more detail will appear, and you can see the amount of detail is quite staggering that you get from these models. You can really see the gaps between portions of concrete and things like expansion joints on the deck itself. Okay, so very nice, easy to use. Just to tell you that that cursor has got a yellow highlighter around it, so you can follow my cursor on the screen. If I press the left mouse button, you'll get a green dot. If I press the right mouse button, you'll see a red dot, slightly larger. And so you can really see how the model is manipulated. If you want to pan, you hold in the right mouse and button and you just pan around. If you want to change your orientation, you use the left mouse button. And so users very, very quickly learn how to do this and basically almost manipulate the model without even thinking about it. And it's highly detailed. Yeah, you can even follow the flow of the storm water into that catch pit there and see it come out, and there's the exit structure for it. So very easy to manipulate. All right, to show you how then this is utilized, there's a measuring tool, and anywhere you click, the first click, it shows the coordinates, and there you will see the Hartebees Hoek 94, Palo 29 coordinates of that point there. The moment you add a second point, it presumes that you're not looking at coordinates. You want to measure, and there you have a measurement, centimeter accurate, 14.3 meters. All right, so any dimension can be taken. Let's have a look. Let's get a height difference. So I'm following, let's have a look. Where this line basically crosses is about there. All right, so if I now need dimension from the top of the deck to the road below on center line, the 8.34 meters. You can also take measurements ongoing where you are measuring length entities. And as you see the latest one there, 97 meters. You can also take long sections, cross sections easily with the section tool. Let's click there on the point of the road there as a reference and the point of the road there, road markings. Right click, and there it generates a cross-section view of all entities on that. As you change the scale, it adds more grillage values and it traces the profile so you can see the elevation of any point on this profile. All of these data can be written out in any of those formats. DXF 2D, DXF 3D, then it's a 3D entity that has all the coordinate values and levels on the 3D line, JPEG, TIFF, bitmap, all the other formats are supported as well. And you will see then, this is typically what I've done with the CAD drawing. I have produced I've taken the 3D DXF line of that profile, added my own little grillage to it and annotations to it, and these then are measured values from the model viewer. We have road grades and elevations of entities illustrated on the drawing. Very easy to do. Okay, so yeah, very impressive, very easy to use. Also is the volume and area calculations. Just to show you how I would get the view right and then use the area tool. Click very carefully on exactly the entities where it needs to place the cursor. There we go, follow the edge of the curb line there. Come this side. Okay, right click and it closes the polygon. It calculates, and you will find from this then things like the circumference, the perimeter. So the curb line right around this area is 70.3 339 meters, and the 2D, two-dimensional area is 302 square meters. And if this was a heap of soil or embankment, whatever, and we traced around the base of the embankment or the heaps of soil or product, coal product or anything, then obviously the volume would be of interest to us, where it then forms the best fit surface of all the bottom of all the points that you've provided or traced, and it would show you then volume above and volume below and the total volume as can be seen by this output here. All right, so it's very useful. And then the other output then from the model is the point cloud itself. We generate a 3D point cloud from this, which then can be read into AutoCAD or Civil 3D or programs like Revit, where the entire structure is available to you for modeling, for taking cross sections, for adding details, or using it as a site plan in which you develop your own new structures or additions. Very easy and very well utilized modeling that goes along with the uses of those BIM type technology software. I hope you've seen easily and seen well from what I've illustrated how extremely user-friendly it is to utilize the data. The last thing that I just want to show you is where would one go or collect these data. I'm opening a spreadsheet program now that I think would be a good place to assemble all the data for bridge inspections. I've termed this data sheet for bridges surveyed, last updated, and one would put in the tables here the item number, the bridge number, bridge location. So for instance, the N1, the crossing road is say 14th Avenue, a type description, 6-lane highway overpass, a date surveyed, and a link to Google Earth. If you click on the link, it opens Google Earth and it takes you right to the bridge. So if you want to see, oh, where is this bridge? What does it look like? Then it's nice for the spreadsheet to already have links towards that. Coordinate values, general bridge status, actions required, remedial work required, and you can click in there and quickly scan through the notes of whatever was necessary on that bridge. Maintenance work required and further inspections. This could also link to other Excel files where you have one Excel file that contains all the data of the bridge inspection, photographs, executive summary, and the planning notes for remedial work or maintenance work. So all of that data would then come together in a single spreadsheet that contains all the data, and as you populate those spreadsheets, it then fills in the data on the side so that everything's at your fingertips. Okay, that's all from me. God bless, keep well.